All right, buckle up, everybody, because we're going deep on LLMs, large language models, and get this, just to train one, you'd need enough water to fill up a whole nuclear reactor's cooling tower.
It's pretty wild. Yeah, the sheer scale of the computing power is just massive.
You sent me some really fascinating stuff to read up on, articles and research and all that. So what's the big picture? What's got everyone so hyped up about these LLMs?
Well, it's kind of revolutionizing the way we use and think about language, you know? I mean, we're talking models that can whip up different creative text formats, translate languages on the fly, give you super informative answers to just about anything. Heck, even write computer code.
Okay, yeah, I see why that's catching people's attention. But let's back up a sec. You know, in those articles you sent over, it all started with those rule-based systems way back in the 50s, right?
Exactly. It was kind of like trying to bash a square peg into a round hole, forcing computers to learn grammar through this huge list of rules. Worked okay for the simple stuff, but real human language. Way too nuanced and complex for that.
So how do we get from those clunky rule-based systems to these super advanced LLMs we're talking about now?
Oh man, it's been a wild ride. So in the 80s and 90s, statistical models came along. Instead of those hard-coded rules, these models use stats to predict the likelihood of, like, word sequences. Kind of like teaching a computer by feeding it a whole library and letting it figure out the patterns on its own.
Ah, so it's almost like learning by osmosis.
Yeah.
Picking up the regularities of language just by being exposed to a ton of it.
Precisely. And that led to some pretty big leaps, especially in things like speech recognition and machine translation. But even those statistical models have their limits, you know. They could predict words in a sequence, sure, but did they really understand the meaning or the context? Not really.
And that's where neural networks enter the scene, right?
Yeah.
The backbone of our fancy LLMs.
You got it. Mid-2010s, neural networks, especially these things called recurrent neural networks, they started shaking things up in natural language processing. They could handle those more complex relationships between words and sentences. But even they struggled with this thing called long-range dependencies.
Long-range dependencies. Is that like remembering the subject of a sentence even after a whole bunch of descriptive clauses and stuff?
Bingo. And that's where the transformer model, this was back in 2017, that's where it really blew the doors off. Breakthrough in handling those long-range dependencies, and it also made training these huge models way faster.
Yeah, the stuff you sent me, everyone talks about this transformer architecture, like this watershed moment that kicked off all these crazy powerful LLMs we got now.
Yeah, it's like the engine driving all these high-performance LLMs totally revolutionized the field.
And of course, everyone's heard of OpenAI's GPT series, right? From GPT-1 to the massive GPT-3. Now everyone's waiting with bated breath for GPT-4. And each one seems exponentially more powerful than the last.
It's become kind of like an arms race, each new model pushing the boundaries of what we thought was even possible. GPT-3, that one had a whopping 175 billion parameters. It was a huge leap forward. It could do all sorts of crazy stuff, creative text formats, translations, different creative content, answering your questions in a really informative way, even writing code.
175 billion parameters. I can't even imagine. Can you break that down a bit? What do those parameters actually do?
Think of each parameter as a tiny little knob that controls how the model processes information. And by tweaking these billions of knobs during training, the model learns to pick out patterns and relationships in language. Basically, the more parameters you got, the more nuanced and complex the model's understanding gets.
So it's not just about the size of the model, but the fine-tuning of all these parameters that gives it its superpowers.
You got it. Think of it like this, a basic calculator versus a supercomputer. Both can crunch numbers, sure, but the supercomputer's got way more power, so it can handle way more complex problems.
Makes sense. And it's not just GPT out there making waves. There's BERT and its variations like Albert and Roberta. It seems like a whole family of these transformer-based models is popping up.
Yeah, it's a real testament to how fast this field is moving. Researchers are always tweaking and refining the architecture, coming up with new approaches, and all this innovation is leading to some pretty incredible real-world applications.
Okay, that's what I'm really curious about. How are these LLMs actually being used?
Right.
But before we get into that, I'm kind of fascinated by how they learn in the first place. It's all about training on these massive data sets, right?
Oh, yeah, we're talking mountains of data books, articles, websites, code, you name it. They probably trained on it.
So they just, like, force feed the model all this information. How does it even make sense of it all?
It's through a process called unsupervised learning. Imagine giving a kid a stack of books taller than they are and saying, "Figure out how language works, kiddo."
No instructions, just letting the model discover the magic on its own.
Yep, pretty much. The model's given this task, Usually something like predicting the next word in a sequence. And by crunching through all that data, it starts to pick up on the statistical relationships between words and figures out the underlying structure of language.
That's wild.
Yeah.
But this whole process got to be insanely resource intensive, right? We started off talking about the water usage, and I'm guessing the energy consumption is through the roof, too.
Yeah, you're not wrong. Training these massive models takes a ton of computational power, and that comes with a hefty environmental price tag. Remember that nuclear reactor comparison? It's not just a catchy headline. Training a single large language model can use as much energy as a whole small town.
Wow, that's kind of sobering. It's exciting stuff, but we got to be mindful of the impact, too.
Absolutely. And as these models keep getting bigger and more complex, sustainability is becoming a major focus for developers and researchers.
Okay, so we've got the history, the tech behind it, and the environmental costs. But what about the end results? Are LLMs just super sophisticated parrots mimicking what they've been trained on? Or is there something more going on?
Now, that's a question that keeps a lot of AI folks up at night. And there's no easy answer. LLMs are amazing at recognizing and reproducing patterns, but there's definitely evidence that they can go beyond simple mimicry.
Yeah, those articles had some pretty wild examples of LLMs generating totally new stuff, things that weren't directly in their training data.
It's like this, you give a chef a set of ingredients, right? They can come up with a zillion different dishes from that same set. LLMs are kind of similar. They're trained on this finite data set, but they can combine and recombine that information in ways that create something genuinely new.
I like that analogy. It implies a certain kind of creativity, even if it's not exactly the same as human creativity.
It's a really intriguing area to explore the limits and possibilities of AI creativity. Raises all sorts of philosophical questions about what it even means to be creative.
Okay, let's table that philosophical debate for now and get back to the practical side. What are some of the most exciting real-world applications of LLMs that are happening right now?
Well, one area that's generating a ton of buzz is healthcare. The potential for LLMs to revolutionize medicine is huge.
Yeah, I was reading this article about how ChatGPT is being used in neurosurgery, to analyze brain scans and help with planning surgeries.
It's crazy, right? LLMs can process and make sense of those really complex medical images, and that can help surgeons make, better decisions during surgery. And it's not just neurosurgery either. They're being used for gathering patient data more efficiently, maybe even helping doctors diagnose diseases earlier.
That makes me think about, the ethics of it all. Is there any concern about relying on these models for such big decisions?
Oh, for sure. It's something we got to be really careful about. Any tool you use in healthcare has to be, rigorously tested and validated. But the potential upside is so big that we'd be remiss not to explore these applications thoroughly.
I totally agree. And healthcare isn't the only place LLMs are shaking things up. What about education? I can see them being super useful for personalized learning.
You're right on the money there. Imagine every student having access to this personalized AI tutor that can adapt to their own learning style and pace. LLMs could explain things, answer questions, even create practice problems tailored to each student's needs.
That sounds like it could really change the game for education, make it way more accessible and engaging for so many students.
And it could free up teachers to focus on more creative and interactive parts of teaching. It's not about replacing teachers, it's about giving them more tools and support.
That's a super important point, collaboration, not replacement. Speaking of different fields, what about the impact on finance?
Oh, finance is another area where LLMs are making huge waves. They're amazing at crunching huge amounts of data, which is the name of the game in finance. They're being used to assess risk, spot investment opportunities, even automate trading strategies.
I remember reading about Bloomberg GPT, this LLM trained specifically on financial data. They're using it for things like sentiment analysis, figuring out if a news article is good or bad for a company's stock price.
Exactly. And that kind of analysis can be incredibly valuable for making smart investment decisions. They're also being used for fraud detection, predicting market trends, and even giving personalized financial advice.
So from healthcare to education to finance, LLMs are already having a big impact. And then there's software development. Tools like GitHub Copilot are changing the way code is written, right?
Oh, yeah. GitHub Copilot is a great example of how LLMs are revolutionizing things for developers. It's like having an AI pair programmer sitting right next to you, suggesting code, spotting bugs, even generating entire functions based on what you tell it to do.
It seems like you could really speed up development and make coding more accessible, especially for people who are just starting out.
Totally. It's like having this superpowered coding buddy that helps you write better code faster.
Okay, this is all super impressive, but you know me, I always like to play devil's advocate a little. So let's talk about some of the downsides of LLMs. What are some of the concerns people have been raising about this tech?
Well, one of the biggest worries, and we touched on this earlier, is bias. If the data that's used to train these models is biased, the output can be biased too.
Kind of like this saying, garbage in, garbage out.
Exactly. We have to be super careful about the data we use to train these models and come up with ways to reduce that bias.
And there's that thing called information hallucination. It's like the models are making stuff up, telling these plausible-sounding stories that are completely fabricated.
Yeah, that's a big challenge because it erodes trust in the models. We've got to find ways to make them more reliable and transparent so users can understand how they reach their conclusions.
What about the impact on jobs? I know a lot of people are worried about AI automating their jobs away.
Yeah, it's a legitimate concern. We have to be thinking about how we can retrain people for the jobs of the future and make sure that everyone benefits from these technological advancements, not just a select few.
Those are all really important points. It feels like we're at this crucial point with this tech, right? There's this huge potential for good, but these big risks we need to figure out how to handle.
I totally agree. We got to move forward cautiously and thoughtfully, have honest conversations about the ethical implications of LLMs, and build frameworks for responsible AI development.
So where do we go from here? What's the next chapter in the story of LLMs?
Well, one thing's for sure. This innovation train isn't slowing down. We're going to see even more powerful and sophisticated LLMs in the next few years.
And hopefully those advancements will come with a better understanding of the ethical side of things and a commitment to responsible development.
Absolutely. The future of LLMs depends on us figuring out how to use their power while keeping the risks in check. It's a tough challenge, but it's also a huge opportunity.
Well, this has been a fascinating deep dive into the world of LLMs. It's clear this tech is going to have a major impact on our lives in the years to come.
I think so too. It's an exciting time to be in this field, and I'm really curious to see what the future holds.
Thanks for joining us on this journey into the world of LLMs. We hope you found it informative and maybe even a little thought-provoking.
Well, one of the most well-known is, ChatGPT.
Yeah, ChatGPT. It's kind of everywhere you look these days.
It's practically become the poster child for chatbot. What's really amazing is how it's grabbed everyone's attention, People are using it for, writing poems, getting help with homework, all sorts of creative stuff.
It's definitely become the go-to for conversational AI. But Google's not just going to sit back and watch, right?
Yeah.
They've got Bard, their own answer to ChatGPT, and then there's Microsoft. They're integrating ChatGPT tech into their Bing search engine.
It's a three-way race at this point, which is actually good for users. It pushes these companies to keep innovating, making their chatbots smarter, easier to use, more powerful.
And it's not all about chatbots either, is it? The research you sent me talked about a bunch of other tools worth mentioning, like RoomGPT and HomeGPT. They use AI to help you redesign your living spaces.
It's like having an interior designer right there on your computer. You just upload a picture of your room, and these tools will spit out all these different design ideas based on, what you like.
That's wild. AI is really getting into everything, huh? And for those of us who spend way too much time reading research papers, tools like PDF-GPT and Elicit are a lifesaver.
Yeah, those are great. They use LLMs to analyze and summarize documents, pull out the key information, even answer questions about the content. It's like having a research assistant who can actually understand those dense academic papers.
I can see how that would save researchers a ton of time. And for all the coders out there, GitHub Copilot is still pretty mind-blowing.
GitHub Copilot is a total game changer, yeah. It uses LLMs to suggest code completions, find potential bugs, even write whole functions based on your instructions. It's like having another programmer right there in your IDE.
It's all really impressive stuff. But you know me. I like to play devil's advocate a bit.
Yeah.
So let's talk about some of the potential downsides. What are some of the concerns people have about LLMs?
One of the biggest ones, and we talked about this a little earlier, is bias. If the data used to train these models is biased, then the output can be biased too.
Yeah, that makes sense. Like that old saying, garbage in, garbage out.
Exactly. We have to be very, very careful about the data that goes into training these models. And we need to develop, techniques to mitigate that bias.
And then there's information hallucination. That's where the LLM just makes stuff up, tells you a story that sounds totally believable, but is completely made up.
Right. And that's a big problem because it erodes trust in these models. We need to find ways to make them more reliable and transparent so people understand how they're coming up with their answers.
And what about the impact on jobs? I know that's a big worry for a lot of people, that AI is going to automate away their livelihoods.
Yeah, it's a valid concern for sure. We need to be thinking about how we can retrain people for the jobs of the future and make sure everyone benefits from these advances in technology, not just, a small group.
Those are all really important things to consider. It feels like we're at this really pivotal moment with this tech. Huge potential, but also these big risks that we have to figure out.
I agree. We got to proceed carefully and thoughtfully, have those tough conversations about the ethics of LLMs, and develop guidelines for responsible AI development.
So where do we go from here? What's the next chapter in the LLM story?
Well, one thing's for certain. This innovation isn't slowing down. We're going to see even more powerful and sophisticated LLMs in the coming years, that's for sure.
And hopefully, along with those advances, we'll see a deeper understanding of the ethical issues, a commitment to, doing this the right way.
I hope so, too. The future of LLMs really depends on us learning how to harness their power responsibly. It's a challenge, yeah, but it's also a huge opportunity.
Well, this has been a fascinating deep dive into LLMs. I think it's safe to say this tech is going to have a huge impact on all our lives in the years to come.
It really is an exciting time to be following this field, and I can't wait to see what the future holds.
Thanks for joining us on this journey into the world of LLMs. Hope you found it informative, maybe even a little mind-bending. And as always, keep those brains buzzing, folks.